Hypervisors allow multiple virtual machines to run on a single physical host and mediate all I/O operations, including read and write requests. A centralized storage array, such as a SAN or NAS, is typically used to provide shared storage for all of the VMs. Nutanix takes a different, much simpler approach. Its converged architecture incorporates local direct attached storage for faster performance and greater flexibility. Each node in a Nutanix cluster includes flash-based storage to deliver massive IOPS for high performance, as well as hard disk drives for low-cost, high-capacity storage. Adhering to the principles of a software-defined solution, Nutanix implements all control logic as a software-based service. A virtual storage controller runs on each node in the cluster, improving scalability and resilience while preventing performance bottlenecks. With storage and control logic now local to the guest VMs, there's no more need for expensive centralized storage or dedicated storage networks. The Nutanix distributed file system aggregates local storage across all nodes, creating a single storage pool that can be partitioned into one or more data stores. These data stores are then presented to the hypervisor using the standard NFS protocol to provide storage for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would a traditional storage array, there is zero change to the virtual environment. VMs are provisioned and managed as before, but without having to configure LUNs, volumes, or RAID groups. Now let's look at how Nutanix manages a typical write operation. When a guest VM needs to write data, its request is passed to the Nutanix controller, which then executes the write to local flash storage. It's also important to fully protect data so that it is always available, even if a node fails. To ensure the strongest protection, data is replicated synchronously across multiple nodes. For a typical read operation, requests are served by local storage resources. Keeping data local to the VM provides the fastest possible performance. That means for the majority of read requests, data never traverses the network. With many enterprise workloads, the older the data, the less frequently it is requested. When data becomes cold over time, it is migrated from flash memory to more economical hard disk storage. However, if that cold data at any point becomes hot again, meaning it is requested more frequently by a VM, Nutanix automatically promotes the data back into flash for the fastest possible performance. What happens if there is a node failure? Nutanix supports standard high availability capabilities, such as VMware's HA, so a VM will automatically start on another node. If that VM then needs to read or write data, it sends its request to the local Nutanix controller. If the data being read is not local, the controller determines where replica data has been placed and forwards the request to the correct Nutanix controller. The data is then sent back to the local Nutanix controller over a standard Ethernet network. The local Nutanix controller passes the data to the VM through the hypervisor and stores it locally for future access. At the same time, the Nutanix software once again replicates the data throughout the cluster in order to return the full cluster system to a fault-tolerant state. Each Nutanix node runs independently and leverages the Nutanix distributed software architecture to create a completely unified cluster. The Nutanix virtual computing platform integrates as many as 4 independent nodes into a space-efficient 2U appliance. For more overall cluster capacity, nodes can be added seamlessly one at a time with zero downtime. With Nutanix, you can start small and easily expand to achieve truly massive scale. It's perfect for nearly any virtual workload, including virtual desktops and end-user computing deployments, private cloud projects, big data applications, DR initiatives, and more. Nutanix, the virtual computing platform for software-defined data centers.
Workspot VDI 2.0 and DAS 2.0 is the future of end-user computing, and it's insanely simple. You know, in 2012, Amitabh Sinha, Puneet Chawla, and Tai Wang came together to create Workspot, and they brought together a team of industry experts from companies like Citrix and VMware and Microsoft to solve the VDI 1.0 problem. And what is that problem? Well, it's way too complex. If you look at this diagram and you're not familiar, it's pretty overwhelming. But if you have been a part of this world for years, you've probably installed this entire thing and patched and maintained and upgraded and so forth, and it is entirely too complex. Anytime you look at any VDI architecture, it's made of two pieces. The first piece is infrastructure down below here, and that's CPU and network and storage. And you get that running and you get your desktops and your apps and your data going. Well, now that you've got that there, your users and their devices want to access it. Well, how do they get there? Well, that's this part here. That's all the VDI control layer. So you come through that and you authenticate, and there's a broker and there's provisioning, and you finally get your desktop. But you have to make all this work. So what does that timeline look like? Well, in the beginning, you have to buy all the software, and it's very complex, and all the risk is on you. Now, the deployment phase, it takes months, and again, you've got experts coming in, and you've got hardware coming in and all this, and it just takes forever, and it's a lot of expense. And after that, you have operational expense of maintaining and so forth, so CapEx and OpEx. And in the end, the IT organization, like yourself and the end users, are just never happy with the overall experience. But you know what? This problem has actually been solved for some time. Application software is already a cloud service in many parts of the world, and that's certainly in the world of sales and HR and IT. You know, these companies like Siebel and PeopleSoft and BMC have been around for a long time. Application software, massively complex, customizations, and they know cloud services are here to stay. They tried to become cloud services companies, and they couldn't. So instead, Salesforce, Workday, ServiceNow, they built their clouds from scratch. No history, no baggage, and now those companies are leading the way in all of these industries. And that's what we did. We made VDI a service. So in this case here, VDI 1.0 is gone, and the next generation of end-user computing is here, VDI 2.0, and that's where we created the Workspot Cloud. We engineered this to be cloud native, multi-tenant, runs on microservices, and it's instantly and infinitely scalable. Take that and tie that directly into your existing three-tier infrastructure, and even add in hyper-converged infrastructure. And with this, you can get hundreds of desktops up and running in a day, and you can minimize your CapEx and your OpEx costs. We have all sorts of ecosystem vendors in that world, the three-tier world you can see over here, and the hyper-converged over here. We dovetail directly and integrate into their hypervisors and spin up resources on demand. Now next, we made desktop a service also. So this is DAS 2.0, the next generation DAS. This is where we tightly couple in with Microsoft Azure Cloud and offer the whole thing as a cloud service. And in this case here, thousands of desktops can be spun up inside Azure under the control of Workspot and made available to users everywhere. The end user experience is a secure workspace, and that is the Workspot client. So install this on your PC or your Mac or your iOS or your Android devices, and from here, with a single click, you can access your desktops and your Windows apps, your web and SaaS apps, and your files, and securely access them from wherever you are in the world. And if for any reason this needs to be removed from a device, reach in and pull the Workspot client right off, and everything is gone, nothing is left behind. With this architecture, both in the cloud and on the client, this summer in VMworld, we won Best of VMworld 2016 Gold Award for desktop and application delivery against all of the VDI vendors vying for this award. So if you're ready to transform your end-user computing deployment, this is the roadmap and the blueprint for that. Forget VDI 1.0, leave that in the past, never install that again. The VDI 2.0 Workspot Cloud is available for you instantly to tie into your existing three-tier architecture and your hyper-converged architecture. And when you're ready to go pure cloud-based, go to DAS 2.0 and find Workspot tightly coupled in with Microsoft Azure as an integrated offering. And whether it's a single instance or it is multiple instances across the globe, it's time to move off of that complexity and cost and inability to scale and move over to VDI 2.0 across multiple data centers, integrating them all together and modernizing them, and then moving even further into desktop as a service 2.0, where you have modernized data centers combined with full-on cloud offerings. Go to workspot.com and hit the resources tab, and you're going to find all sorts of rich content to learn more about why Workspot VDI 2.0 and DAS 2.0 is the future of end-user computing.
Every company today is in the middle of a digital transformation. And at the same time, they're really trying to cope with how does IT respond to this need for faster access to information and data. Because really there are two populations inside of every business. There's data managers responsible for the control, management, and protection of the data. And then there's this ever-growing population of data consumers. They want more data, they want more copies of data, and they want it faster than they've ever had it before. And the problem is, data's gotten too big to really move quickly. Data has become more diverse, and data has become more heterogeneous in terms of its location. It might be in a cloud, it might be in another data center. All of this puts pressure on IT to respond. Now, the answer is simple. The answer is delivering that enterprise data as a service, and Actifio software does just that. Actifio software gets that data, regardless of what it is, regardless of where it is. It virtualizes it, so it becomes immensely portable, and then it provides instant use of that data for any number of use cases: automation, movement and migration, protection and recovery, and even development and test. An enterprise that is using enterprise data as a service software from Actifio moves faster, has greater assurance of the recoverability and protection of their data, and is actually not constrained by any one vendor selection because it's completely independent of infrastructure, clouds, and any technology shift that might come in the next 3 to 5 years. Enterprise data as a service from Actifio is something that can be transformational at the enterprise level, and yet you can get started fast. We would encourage you to contact Actifio to learn how you can get started on the enterprise transformation in days and start to get instant value from your data for development and test operations, protection and recovery, migration and movement, and again, all within days.
Let's talk about how the internet works. First thing to note, it's all built around routers. You see, routers receive packets of information with to and from addresses, and use this to address to find a path to the packet's destination. That path usually passes through multiple routers, and because each packet is routed individually, nearly identical packets can take completely different routes. In theory, this optimizes for the best path between two endpoints and allows the network to self-heal when a path isn't working. However, routers weren't designed to do everything, so more technology has been developed along the way. Firewalls only permit packets from authorized or requested sources, preventing everything from suspicious port scans to volumetric denial of service attacks. Gotta have those. Load balancers scale application services by distributing packets across multiple identical servers to keep traffic moving smoothly. Toss them in too. Deep packet inspection devices gather information for network security and management purposes. Added. Network address translation devices divvy up a small number of public IP addresses to be shared by a larger number of endpoints. Throw them on the pile. We're not just talking about physical boxes either. The trend of network function virtualization turns many of these devices into connectable software appliances. What's more, controlling how packets move between endpoints and through network devices often involves overlay or tunneling network techniques, such as MPLS or VPN. Making all this work together reliably and securely requires near-perfect configuration, control, and orchestration. But what if, instead of piling on the tech and creating a complex, fragile mess, we rethink routing? 128 Technology has developed a session-aware router that allows networks to operate in a fundamentally better way, with more security, control, and agility. These routers understand unique characteristics about the bidirectional flow of packets in a session, including source, the initiator of the session, and destination addresses, directionality, along with other session-specific attributes, all of which are used to connect related flows into a single session. Because of this, the router can determine the start or lead packet for each and every session, understand the session-specific data in the packet, and intelligently route the session to its destination via the best path available. In doing this, the router changes the packet's source and destination addresses to waypoint addresses, understood by 128 Technology routers. The original addresses, along with other information, remain with the packet and are stored as encrypted metadata. subsequent packets from the same session are automatically recognized and forwarded along in the same way, but without first packet processing. If the 128 technology router receives a packet and sees the metadata has been changed, modified, or faked in any way, it's discarded. Just before a packet reaches its destination, the metadata is extracted, and the original source and destination addresses are restored. The router applies the same treatment to the entire session, including packets returning to the source, processing them bidirectionally. When it detects that a session has ended, the routers eliminate any and all information about that session, further protecting the network's security. These session-based concepts, session awareness, first packet processing, and waypoints are the building blocks of a highly disruptive networking paradigm. We call it secure vector routing. It allows you to put load balancing and firewall security in every step, traffic steering across the network, and gain rich, deep insights into your network services. It's a completely new way to think about routing, and it's from 128 Technology.